Hello, this is the review packet, problem number 32. I want to talk a little bit about energy diagrams and what you need to know and what you don't really need to know. So, big thing you need to know about energy diagrams is they tell us about the energy story during a reaction. So you've got a diagram that looks a little bit like this. Your y-axis represents energy and your x-axis represents reaction progress. So you can kind of think of this as being basically time, right, as the reaction goes by. And we always have some starting energy, that's arbitrary, and you always need to have a little bit of energy in. There's always a little bit of energy in and a little bit of energy out. And what those things represent, so like here's my reactants, here's my products. The energy in represents, so that increase in energy here initially, let me use a different color pen here. So this initial input is the energy to break the bonds that you're starting with. So breaking bonds takes energy. So atoms are attracted to each other. If you want to pull them apart, it's kind of like tearing apart Velcro. That's going to take energy input. And then that amount that it goes down, this represents the energy released from forming new bonds. So sticking things together releases energy. So this is energy released, and this is energy input. And I wouldn't worry so much about the numbers down here, like adding things up and being able to give me a number for the energy from making products or breaking bonds. But what it is important to know is if you're looking at a diagram like this, this diagram represents an exothermic reaction. And that means that there is overall a net release of energy. So you think exothermic, energy is exiting the system. And the reason why energy is exiting the system is because there is more energy released from forming those new bonds than is absorbed, maybe would be the word for it, from breaking those initial bonds. So I'd say don't worry about, again, assigning like particular numbers here. You just want to be able to recognize whether reactions are exothermic or endothermic and what that means in terms of how much energy it took to break the bonds or form those new bonds.